Before I do any problems, I want to talk about Newton's first law, give you a little background, a little perspective on where it came from and what various other opinions have been regarding the nature of objects. Essentially, Newton's first law addresses how do objects, if left to their own devices, behave. Left to their own devices essentially means there are no pushes or pulls on them. Pushes or pulls are what we call forces. You all have an intuitive idea of what a force is, although we don't really have any good measurement of exactly quantitatively, operationally, how do we define force. I'm sure by now you've all encountered the unit of force called a Newton, and you all, of course, from everyday life know the unit of force called the pound. But how those are precisely defined, that really has to wait until we get to Newton's second law. And then we'll talk about precisely what is 1 Newton of force. But for the time being, let's just say that 1 Newton is about 1/4 of a pound. That'll do for now. We're not going to do anything real quantitative in this video anyway. The first person to really think how an object behaves if left to its own devices was the Greek philosopher Aristotle. And he lived during the time of about 350 BC. And he looked around him and he observed the way things happened. If he took a ball and he threw it, eventually it came down to the ground and came to rest. And so he thought, aha, the natural state of all earthly objects is to be at rest on the ground. Now there's a corollary to this. Apparently an object, when dropped, seeks out its natural state, which is to be at rest on the ground. And so he thought it was obvious, therefore, that a heavier object would seek out the ground, its natural state, more strongly. And therefore, to him, it was obvious that the heavier object would reach the ground first, because in essence, it was trying harder to get there. So this is essentially to what today we call Aristotelian natural philosophy. And through the 19th century, the sciences in general were referred to as natural philosophy, because philosophy is where all the sciences had their beginnings. And here's an amazing thing. This notion that if you have two objects and you drop them, that the heavier one will obviously reach the ground first. For 2,000 years, nobody ever tried it. Now, the guy that tried it, of course, and you probably have heard this story, which may in fact be just a legend, which isn't true, but it's a good story anyway. Galileo, who discovered, as you have been taught, that there is a uniform acceleration for all objects. He dropped 2 rocks off the Leaning Tower of Pisa, a heavy one and a light one, and indeed they did not have the heavier one get there first. It was a tie. So Galileo, approximately 2,000 years afterwards, discovered that there was something wrong with Aristotelian natural philosophy. Now, Galileo was essentially the father of kinematics. Most of what you've done so far this semester has been kinematics, and Galileo was the first one to sort of get that sorted out, make measurements. Like I say, he measured the acceleration due to gravity. You have to realize Galileo had really crummy clocks, and so it was not easy to measure the acceleration due to gravity. He had to be very clever, and clever means essentially he had long inclined planes where objects rolled down, and he could measure the acceleration using the crude clocks that he had at his disposal at the time. But Galileo never addressed what is it that makes something accelerate. That had to wait for someone else. Notice that Galileo died in 1642, and in 1642, Isaac Newton was born. Sort of an interesting coincidence. At any rate, Newton eventually thought about physics, took the experimental evidence of things like what Galileo had done, also a lot of stuff from astronomy, the way the planets move, the way the moon moves, things like that. Those sorts of things you'll study later in the year, I'm sure, using Newtonian mechanics. But Newton, first of all, he had to introduce calculus. In order to really develop physics fully, one needs a whole new branch of mathematics, and Newton had to invent calculus before he could do physics. At any rate, Newton had enunciated in his famous book Principia, which was all written in Latin, which was sort of the what all scholarly treatises were written in the 17th and 18th centuries. And he basically enunciated three laws. And the first law says that an object which is totally on its own, that is, there are no external forces acting on it, will either remain at rest, if it is at rest, or it will remain moving with a constant velocity. And since a velocity is a vector quantity, that means that the object will continue moving in a straight line with constant speed, speed being the magnitude of the velocity vector. Now, all of you today probably don't find this surprising at all, but in the 17th century it was absolutely an amazing jump forward, because there were more than 2,000 years of traditional Aristotelian physics behind him, which said just the opposite, that an object which is not at rest will eventually come to rest on its own accord. Newton realized that, in fact, the reason that a thrown ball eventually comes to rest is because there are forces pushing on it. If you take a hockey puck on an ice rink and give it a push, it might go 5 or 10 meters. If you push it harder, it might go further. The reason is because the ice is exerting a force on it, which is slowing it down. If you made that ice perfectly slippery and you gave that hockey puck a push, it would go forever. So Newton's first law basically says that an object at rest remains at rest unless a force acts on it, and an object which is moving, if it has no forces on it, moves with a constant speed in a straight line. Let's talk briefly about what a force is. For this part of your physics course, a force is simply a push or a pull. And for all intents and purposes, until you get to the second semester, all forces are one of two kinds. The first kind is the gravitational force. That's the force that causes something to accelerate if you drop it, and you've done that kind of problem. The force which the Earth exerts on an object is called its weight. Now don't confuse this with mass. Later on when we talk in more detail in terms of forces and find out what forces really are, there we will find that force and mass are different quantities. And so the weight of an object is one force that we'll find. The other force is called a contact force, and it's a force that an object experiences by virtue of its contact with some other object. And so if you are pushing a box across the floor, there's a contact force which the floor exerts on the box, and there's a contact force which your hands exert on the box. And of course, the box also has its own weight. So let us continue now to the next video. In the next video, I want to do some examples of Newton's first law. And these are going to be what appear to be totally trivial examples, but I think that it's a very good idea to start off with something which is easy to understand rather than start off with something which is tricky to understand. And so as you'll see in the next video, I'm going to take things very slowly. I'm going to first of all give you a method of attack for Newton's first law problems, which will also be a method of attack for Newton's second law problems. And then I'm going to give you what are essentially problems that you could solve in your head if you understand conceptually what Newton's first laws are, what Newton's first law is. And but we're not going to solve it in our head. We're going to solve it very carefully using the method which I suggest. Okay, so I'm ready to move on to the next video.